As we discussed in the previous lecture, discounting is the act of bringing future cash flows into the present day. To calculate this, we actually use the present value formula. Here it is. The present value of a single cash flow equals the cash flow at time n over 1 plus r to the time n, where r equals our discount rate. I want to mention that r, our discount rate, is actually a generalized term that encompasses any of the rates or percentages that we use to discount our cash flows. So just stay flexible in the way that we define our discount factor in our present value analyses, because they change depending on the context of the question and the example. Okay, if this equation looks familiar, you have a really good eye. This formula is simply derived from our future value formula, except instead of saying future value, we actually use cash flow at time n. However, future value and cash flow at time n are kind of the same thing because a cash flow at time n is a projected cash flow to occur sometime in the future. Okay, let's do a quick example with this. You want to put a $40,000 down payment on a house in 2 years. You can put your money into the stock market and expect a return of 12%. How much stock do you need to buy today to have $40,000 in 2 years' time? Okay, take a minute here to pause the video and try to answer this question on your own. Okay, welcome back. Since you want to have $40,000 in 2 years' time, we need to discount $40,000 2 years backwards. That means $40,000 is our cash flow at time n, our R is 12%, and our N is 2. So if you set up this equation with those variables, it should look something like this. Our next step is to simply use arithmetic to calculate this. When you raise 1.12 to the second power, you get roughly 1.25. And then dividing 40,000 by 1.25 gives you $31,887. This means that if you want $40,000 in 2 years, or a future value of $40,000, you must place $31,887 into your stock trading account, earning 12% each year today. In simpler terms, the present value of $40,000 in 2 years is $31,887, since that's what you would need to invest today to have $40,000 in 2 years' time. Okay, let's put this into action in Excel with our first example. Let's say you won a small lotto prize. You're given the choice to receive $1,000 today or $1,300 in 2 years. The interest rate is currently 15%. Okay, here's the problem translated into our Excel spreadsheet. You can either take that $1,000 today or at time 0, or you can take $1,300 at time 2. Our goal is to calculate the present value of our future cash flows and compare them in this leftmost column. For the first option, if we take $1,000 today, no calculation is actually needed. This is because the present value of any cash flows received today are just the amount of those cash flows, no discounting required. For you math nerds, if you take a look at the formula closely up here, it is because the cash flows received today would have an n of 0, and anything raised to the 0th power is 1. So the denominator would be 1, and therefore the present value of a single cash flow would just evaluate to that cash flow. However, the present value of option 2 should return something different. Let's go ahead and try to calculate this with our present value formula up here. Let's type equals, and the future value of our money, $1,300, and then we divide it by 1 plus R, which is 15%, raised to the nth power, which is 2 periods. When I hit enter, you see that the present value of the $1,300 in 2 years is actually $982. Since $982 is less than $1,000, we should take the payment today because the present value of the payment today is higher than the payment in 2 years.